You know, for decades, the world of software has been all about two things: speed and features. But what if that's the wrong way to look at it? What if the real question isn't how fast we can build something, but how long that something can actually last? That's really the heart of this idea called eco-programming.
So, let's kick things off with a question that I know is going to sound a little weird. What on earth do bagels have to do with the future of software? Stick with me here, because this is the central metaphor in the sources we're digging into today, and it just brilliantly captures this massive problem that's growing right under our noses.
Okay, so here's that metaphor in action. On the left, you've got what's called Bagel Software. Just picture it. A huge, ever-expanding body of code. That's the dough. It just gets bigger and bigger. But right in the middle, where the core logic and the actual algorithm should be, there's just a hole. It's gotten completely lost, totally invisible. But on the right, you have Muffin Software. It's solid, it's coherent. The algorithm, the whole point of the thing, is right there in the center, visible and solid. The entire system is built around it, not just piled on top of it.
Now, this is where it gets really urgent. With this explosion in AI-generated code, we can now produce that dough, that bagel, at a mind-blowing speed. This quote just says it all. AI can bake software bagels faster than ever before. We're not just creating these hollow systems, we're doing it at a scale we've never seen, completely losing the plot along the way. And look, this isn't just about one bad program or one messy project. When you have this happening millions of times, all over the world, it stops being a local problem. It becomes a systemic risk. And that leads us to this really powerful concept: digital pollution.
So what exactly is digital pollution? Well, the formal definition is the buildup of these fragile, opaque, and frankly unsustainable software systems. The best way to think about it is like environmental pollution, but for our digital lives. It's this invisible rot that accumulates over time, and it threatens the stability of the entire digital foundation we all rely on for everything. And if you're in the tech world, these symptoms probably sound painfully familiar. You've got these opaque architectures where no one can figure out how anything really works. Technical debt just spirals completely out of control. Systems get so brittle and fragile that you can't update them without breaking everything. And then there's the scariest one. You end up with these massive, critical code bases that absolutely nobody, not one single person on the planet, fully understands anymore.
Okay, so what's the solution? How do we clean this up? Well, the sources here argue for a really human approach. It's not just about finding a better tool. It's about a fundamental shift in identity for the people building this stuff. It's about seeing the programmer as a steward.
And this brings us right to the central ethical question, doesn't it? Who is actually responsible for the long-term health of the systems we built? Is our job just to ship the next feature and move on? Or do we have a deeper responsibility to make sure that what we build today is still going to be healthy and usable and maintainable years or even decades from now?
You know, this idea of a steward fits perfectly into the history of the profession. Think about it. Back in the 50s, people who wrote programs were just called coders. Then, after the so-called software crisis of 1968, the field needed more discipline, and the title software engineer was born. The argument now is that we're at another one of those moments. The next crucial evolution is from engineer to digital steward.
So, what is digital stewardship? It's a professional ethic. It's this recognition that developers aren't just building standalone products. They are creating and maintaining entire digital ecosystems that have to live for a very, very long time. And the key part is that with that role comes a deep responsibility for the long-term health and sustainability of those systems.
Now, having a new ethic is great, but talk is cheap, right? To make this real, to make it practical, you need a way to actually measure it. If we're really going to start valuing sustainability, we need some kind of compass to tell us if we're heading in the right direction. We need to start measuring what truly matters.
I mean, the logic here is just incredibly simple. If we say we value software sustainability, then we absolutely have to be able to measure it. It's that old saying, right? You can't improve what you don't measure. An ethic without a practice is, well, it's just a nice idea. And the proposed tool to do this is something called the Methodological Sustainability Index, or MSI. Now, what's crucial here is what this doesn't measure. It's not about speed or features or performance. It's all about a system's long-term health. It looks at things like evolvability. Can this system actually grow and change? It looks at architectural integrity and that algorithmic transparency. In other words, can you still find the muffin inside that bagel? So let's just tie this all together. This slide really lays out the whole argument in a perfect chain of logic. You start with the AI code explosion. That makes it easier than ever to create Bagel software. Piles of that stuff create systemic digital pollution. Our moral and professional response to that pollution has to be digital stewardship, and the practical tool that makes that stewardship possible is the MSI. See? Every step just flows right into the next.
And let's be really clear, the stakes here could not be higher. This isn't some abstract academic debate for engineers. As the source material puts it, the future of civilization will depend increasingly on the reliability and sustainability of software systems. Our finances, our infrastructure, our healthcare. Pretty much everything runs on this digital foundation. If it crumbles, we are in serious trouble.
So we end with this really powerful reframing of the whole problem. For decades, the tech industry has been completely obsessed with one question: how can we go faster? The argument here is that maybe we've been asking the wrong question all along. The real challenge, the most important question for our generation is this: how do we build digital systems that don't just work today, but that remain healthy, understandable, and truly sustainable for generations to come?